Syllabus deemed university, building Young India.
Hi everyone, I am Dr. A.R. Babu, working as an assistant professor in Department of EEE, Vignan's Foundation for Science, Technology and Research, deemed to be University. And welcome to my lecture series on energy audit, conservation and management. So we have already gone through 4 units in this Eacm. Right, in the first unit we have already gone through the basic principles of energy management. In the second unit we have gone through cogeneration, trigeneration and waste heat recovery. In the third unit we have gone through energy efficient illumination systems. And in the fourth unit recently we have gone through energy efficiency in electrical appliances. The last and the final unit of this lecture series on energy audit, conservation and management is energy efficiency in space heating and ventilation. This is the syllabus of this particular unit number 5, that is energy efficiency in space heating and ventilation. We are going to see what is ventilation, what is air conditioning, and then we are also going to see some heating techniques, and that's why this complete unit is called HVAC systems, that is heating, ventilation and air conditioning systems we are going to see. We are going to see heating of buildings, transfer of heat in terms of different modes like conduction, convection and radiation. And we are going to see some space heating methods, and we are also going to see electrical water heating systems and energy conservation methods. And coming to the learning objectives of this today's class, we are going to see what is HVAC, what is the need of HVAC, then we are going to see what is ventilation, what are the different types of ventilations. There are 2 different types of ventilations, that is natural ventilation and forced ventilations, right? And we are going to see in depth about this ventilation, and then we are going to see the concept of water heating as well as space heating, and then we are going to see what is a solar water heating system. It consists of again 2 methods, thermosiphon system or natural circulation system, or on the other hand forced circulation system. And then we are going to see space heating methods. There are 2 different types of space heating methods. One is a passive space heating method, other one is a active space heating method. This passive space heating method is called Trombe wall method, and the active space heating method by using external supply. And all these things we are going to see. And finally we are going to see what are the different electrical water heating systems, like what is a geyser and what is a immersion heater. And finally we are going to see the air conditioning, that is the working of air conditioning system. And all these things we are going to see in this particular subject. So the first learning objective of this unit is what is HVAC, and then what is the need of HVAC, and later we are going to see in depth about this HVAC. And this unit consists of 3 different modules. The first module is ventilation, second module is heating, and third module is air conditioning. And then we are going to see about the ventilation. So what is ventilation, what are the different types of ventilations, right? So in that sense, what is a forced ventilation and what is a natural ventilation, we are going to see in this particular unit as a learning objective. Later we are going to see different heating techniques like water heating technique and space heating technique. So in the space heating technique we are going to see 2 different types. It is a passive space heating technique and active space heating technique. And in the water heating system, and this water heating system works on the principle of joule heating. From this joule heating there are 2 different types of water heating systems are available. They are immersion heater and geyser, and we are going to see in depth about these water and space heating systems. And finally the third module deals with air conditioning. There we are going to see what is the working principle of air conditioner, that is vapor compression cycle, and later we are going to see what is the working of air conditioning system. Now let's start our unit number 5, that is what is HVAC. So HVAC stands for heating, ventilation and air conditioning. So HVAC refers to the different systems used for moving air between indoor and outdoor areas, along with heating and cooling both residential and commercial buildings. So in both the residential and commercial building, HVAC refers to the different systems used for the movement of the air between indoor and outdoor areas, along with heating and cooling. And all these 3 basic requirements will be performed by HVAC, that is heating, cooling as well as ventilation, right? These are the systems that keeps you warm and cozy in the winter, and they will keep you feel cool and fresh in the summer. They also are the systems that filter and clean indoor air to keep you healthy and maintain humidity levels at optimum comfortable levels. So they are the systems that filter and clean indoor air to keep you healthy. And one more thing is, they'll maintain the humidity levels at optimum comfort levels inside a building. All these are the different concepts of HVAC. So what does HVAC do? So the HVAC is a basic requirement for the indoor air quality at a breathable level, as well as temperature and humidity in the house. So this HVAC bothers about three different things. One is the indoor air quality, temperature and humidity inside your house or a closed space. And these three things will be taken care by the HVAC system. So the term HVAC means entire air system of the home. The entire air system of your home will be controlled by the HVAC devices. So why we need HVAC systems? So improvement of air quality, then moisture regulation, then avoids depression, then maintenance of constant temperature throughout the year. Be it be summer or winter, it will maintain constant temperature throughout the year. Then energy conservation. Because of all these five things, we need HVAC system. It will improve the indoor air quality to our breathable level. At the same time, it will regulate the moisture inside the space. As well as, if you are depressed, the environment inside your room will elevate or deprove your depression. So if the environment is good, your depression will be avoided, or on the other hand, your depression will be elevated. So this HVAC will take care about the entire air system of a closed space and keeps you away from depression. As well as, it will maintain a constant temperature throughout the year, be it be summer or winter. And the final one is the energy conservation. By using this HVAC system, you can conserve the energy in your home. And all these five needs make this HVAC a important component of everyone's life. Now let's talk about the first module, that is ventilation. So the purpose of HVAC system is more than just warming or cooling a space. Instead, it serves to improve the indoor air quality and provide comfort for everyone inside the building. So the main purpose of it is to improve the indoor air quality, and that task is known as ventilation. So first, there should be a source of fresh air intake from outside or from within the home. In order to have a proper ventilation, we should have a source of fresh air intake. And then ventilation is the intentional introduction of outside air into a space, and this will occur in two different ways. So ventilation is the intentional introduction of outdoor air into a space where you are living in, and this can happen in two different ways, either through natural ventilation or forced or mechanical ventilation. So you need fresh air in order to have a ventilation in your home. So this ventilation can be provided by two means, either by natural ventilation or by forced or mechanical ventilation. Natural ventilation means without using any additional equipments, you could able to get the air into your home because of pressure difference. And forced ventilation or mechanical ventilation means you have to use some mechanical equipment like blowers or fans in order to have a proper ventilation into your closed space or into your home. Let's see one by one. Natural ventilation. See, this natural ventilation is the process of supplying air to and remove air from an indoor space without using mechanical systems. So without the help of the mechanical systems, or without the mechanical system being installed in your room, the flow of air will automatically happens in natural ventilation systems. Either it will bring the fresh air into the room, or it will take the used air from the room into the outside environment. These two things will be performed naturally by means of a natural ventilation system without using any mechanical equipments. So it refers to the flow of external air to an indoor space as a result of pressure difference arising from natural forces. So we are not using any mechanical systems. The only natural system that will circulate the air to and fro the indoor space is pressure difference, the gradient in pressure. The wind will move, or the air will move because of pressure difference. Wind is nothing but air in motion. So because of the natural pressure difference inside your room, because of your construction of that room, automatically there will be a pressure difference created in that room for the circulation of air to and fro the room. As you can see in the picture over here, there is a closed space, and at the bottom you have an inlet on the right side, and on the left side you have a outlet at the top of a wall. So on the right side wall you have an inlet, fresh air intake at the bottom, and on the left side wall there is outlet for the air at the top of the building wall. Now because of the pressure difference, the air will move from inlet to the outlet. The air will always move from high pressure zone to the low pressure zone. Because of natural creation of high pressure and low pressure zones inside the building, automatically there will be a movement of air from high pressure zone to the low pressure zone, and that is why you will get the fresh air circulation into the room through natural ventilation. And let's see it in detail. So natural ventilation is present in most of the homes, as air typically moves in and out through windows, doors, vents and other openings. So in our home we will be generally having doors, windows, vents and other openings. So through them there will be air circulating inside the room or a closed space. So this exchange of air is necessary to replenish oxygen and to remove carbon dioxide, unpleasant odors as well as excessive moisture from inside the closed space. So during night time, in the summer months, natural ventilation can provide free cooling and reduce your home energy use. Instead of using ACs or fans, your natural convection itself will provide sufficient cooling to your bodies and comfortness to your bodies during the summer months. Right? If you have a proper natural ventilating arrangement to your home, right? As you can see in the picture over here, there should be some windows, doors and vents for the air movement into the room as well as from outside the room. So the air have to bring in fresh oxygen into the room, and it have to remove the carbon dioxide as well as excessive odor as well as unpleasant odors and excessive moistures from inside the space to the outside. So you should have that provision. So you should have that provision of supplying the fresh air into the room as well as to remove the carbon dioxide, unpleasant odors and excessive moisture outside of the room. Right. What are the different types of natural ventilation systems? There are two different types of natural ventilation systems. The first one is a wind driven ventilation, second one is a stack ventilation. This wind driven ventilation is again divided into two types. First one is a single sided ventilation, second one is a cross sided ventilation. So on a whole, this natural ventilation is divided into wind driven ventilation and stack ventilation, and this wind driven ventilation will again further divided into single sided ventilation and cross ventilation. Now let us see about these in deep. So coming to the wind driven ventilation, it consists of two types. What are those? Single sided ventilation and cross ventilation. So a single sided ventilation is defined as a condition where one or more openings exist only at one facade of a closed room or building. So as you can see in a single sided ventilation figure over here, you can clearly see that there is only one window available, and from that window only air will be coming in and air will be going out. So there is one window for to and fro motion of the air. Then you will call that ventilation as single sided wind driven ventilation unit. And second one is cross ventilation. So what is cross ventilation? The cross ventilation is defined as a condition where two or more openings exist at two or more facades. Now you can see there is two walls. One is a windward wall, another one is a leeward wall. So what is a windward wall? From which wind will enter the home or a closed space is called a windward wall. And what is a leeward wall? The room or the wall or a window on the wall through which the unpleasant air will move outside the building or a closed space or a room is called a leeward wall. So wind will come from windward wall into the room space, and wind will be taken away through the leeward wall to the outside atmosphere, and this is what a cross ventilation. So you will be having two or more windows or doors or openings for to and fro motion of the wind into and out of the room or a closed space. So in case of a single sided ventilation, there will be only windward wall. Through this windward wall only the air will enters and the air will leaves. So there is no opening in the leeward wall in case of a single sided ventilation. But in case of a cross ventilation, the air will enter through windward wall and the air will leave through leeward wall. Right? These are the different wind driven ventilation systems. And then the second type is a stack ventilation. The stack ventilation is a combination of cross ventilation and buoyancy. What is this buoyancy? Warm air rising up is nothing but a buoyancy effect. So the stack ventilation is a combination of both cross ventilation and buoyancy effect. And this cross ventilation is also known as buoyancy or thermal ventilation, and it is primarily induced by temperature difference within a home, right? So as air in a room heats up, it becomes less dense, which causes the air to rise. It's a basic principle. Whenever you heat the air, automatically the density of the air will decrease and it becomes light and it will move upwards. And this warm air will leave your home through a window or opening located higher in the home or a room or a closed space, which results in cool fresh air entering through lower windows. As you can see in this figure, it's clearly evident that the cool air will come from both the windward wall as well as the leeward wall into the home, and once it gets heated up because of the sun's heat or because of the heat of the objects which is inside the room, then obviously the air will become hot, and hot air, the density will become less, and obviously the air will move to the top, otherwise the air will move to the ceiling, and in the ceiling we will provide two vents or windows or openings for the hot air to move outside the home, and that is the reason why the cold air will enter through windward and leeward walls and leaves through hot air and leaves through the windows which are available at the ceiling, right? So because stack ventilation does not rely on wind, it can take place with relatively stable airflow on hot summer days with no wind. So no wind is required. It's because of the pressure difference and temperature difference. It's because of the temperature difference the air circulation will happen inside this stack ventilation unit. And there, even when you have no wind, the system will work and provide ventilation to your home. So on a whole, ventilation is nothing but giving comfort to your body or to the persons who are residing inside that closed space. It has to bring the fresh air into the building, and it has to remove the hot air from the building, and in such a way that comfort will be provided to the occupants of that closed space or room. So now let's see the second ventilation technique, that is a forced ventilation or mechanical ventilation. So a type of building ventilation system that uses fans or blowers to provide fresh air to rooms when the forces of air pressure and gravity are not enough to circulate air through the building. So when naturally occurring pressure difference and temperature difference and gravity will not cause proper ventilation to your home, you have to go for forced ventilation systems. And this forced ventilation system will provide that extra gradient in pressure and temperature, so that the air will be bring into the home as well as the air will be removed from the home by means of fans or blowers, right? So the forced ventilation uses a mechanical systems to move air in and out of a closed space or home. So in the past there was plenty of natural ventilation in most homes, but however the modern construction is creating homes that are far more tightly sealed, so that ventilation is becoming an important component in home HVAC systems. So nowadays we are living in a concrete jungle, and most of us are living in apartments. So in apartments we don't be having any space for the windows or ventilation systems, because they will be side by side. If you have an individual house and if there is a garden around it, then obviously you will be having plenty of ventilation. But in the modern era, because the land is getting very very costly, we are moving into the concrete buildings where there is no scope for ventilation. So forced ventilation is mandatory, because natural ventilation will not be provided itself in those concrete buildings. So obviously we require forced ventilation to provide comfort and ventilation to us, and that is why forced ventilation comes into existence in the modern constructions. So now let's see. So once the air is brought in, it is drawn into an air handling unit where the work begins. Here, air is drawn through filters to remove the dirt, dust, allergens and other particles. Next up is comfort. Once you filter the air from all the dust particles, the next one is you require comfort. So air is either sent to the heated or sent to be cooled. Air is either sent to be heated or sent to be cooled or have excess humidity removed. So in order to have comfort, we need to either heat the air or we need to either cool the air or we need to remove the moisture or humidity content from the air. When you do any of these three things, then automatically you will get the required comfort through ventilation. As you can see in the figure over here, you can see the air will enter from the top duct, and after entering there, the air will enter to the air handling unit where it has three provisions. So the first one is heating, second one is cooling and third one is humidity removal. So any of these three or all the three will be performed and it will remove the fresh air into the living space of your closed room or building or house. In that way you will get comfort. Now let's see this figure. Now let's see the working of a forced ventilation system. So you can see on the top I have shown a heat recovery ventilation unit, HRV unit. And that HRV unit will be having two openings. One is for the air to send into the building, another one is to collect the air from the building into the outside space. So that is installed on a building, right? So it is a heat recovery ventilation unit, and by means of that, by providing electricity, so it will work on electricity. So whenever you plug in, it will be nothing but a blower or fan. So automatically air will be sent into the building. So you can see the black color solid line represents the air. Now you can see it here that the rhombus shaped opening is nothing but a ceiling exhaust grills, and the circular openings are nothing but ceiling supply grills. So circular means ceiling supply, rhombus means ceiling exhaust. That means exhaust means they will remove the air from within the space. Circle means they will bring the air into the space. And you can see that hashed line means ventilation supply ducts, and the solid line means ventilation exhaust ducts. So this is nothing but a piping. So this hashed lines indicates the piping through which the ventilation enters the rooms, and this solid line represents the ducts through which air exits the home, right? Now you can see it here clearly. You can see from your bathrooms, right, from all the bathrooms you can remove the air through solid black colored ventilation exhaust ducts. There you can see the circle shaped ducts which are indicating the ceiling supply grills through which the air will leaves the room, the hot air, and cold air will enter the room through hashed ducts or rhombus shaped ducts. As you can clearly see it here, the air will be entering into the room through circular ducts and hashed ventilation supply ducts. As you can see in the figure, the fresh air will enter the home through ventilation supply ducts as well as the circle shaped ceiling supply grills. Right, to the ceilings it will provide the ventilation, and from the ceilings the air will enter the homes or the rooms. You can see there are 3 bedrooms over there and the living room, and to these 4 rooms the air will be entered from the ceiling through ceiling ducts, ventilation ducts, and from the bathrooms, from all the 3 bathrooms in 3 bedrooms as well as from the kitchen, you will remove the air, and that air will be taken into the heat recovery unit where it will be sent outside. So it is how the forced ventilation system will work.